Okay, welcome to the Cannabis Plant Science and Cultivation webinar for September. We will begin shortly, and I would like to allow a brief moment for attendees to join the webinar. Maybe we can wait another minute or so, and then we can get started shortly. Okay, greetings. I'm Sang Park, a senior scientist and the chair of the ICR Cannabis Plant Science and Cultivation webinar series. I extend a warm welcome to everyone joining us for our September webinar. This webinar series is co-hosted by Dr. Nirit Bernstein of the Volcani Institute in Israel. We have the privilege of featuring renowned professors in the field of cannabis. We hope that these distinguished speakers will provide you with excellent insight into the science of cannabis plants and cultivation. Please consider sharing this webinar with your colleagues and students, and do not hesitate to nominate potential speakers for future sessions. Today's presentation will last approximately 40 minutes and will be followed by a short question and answer period. To ask questions, please utilize the Q&A feature in the Zoom toolbar. For any technical issues or general questions, please use the chat function. Now, without further ado, I would like to pass the floor to today's moderator and co-host, Nirit.
Hi, hello everyone. Thank you it's wonderful that you all joined us today. I would like to introduce our speaker, Professor Jim Faust. Is a professor of floriculture physiology at Clemson University in South Carolina, United States, where he teaches hydroponics and greenhouse production courses, and he does research on cannabis mother plant production, propagation, height control, flowering, and post-harvest drying and curing. Professor Faust and Dr. Allison Justice started the Cannabis Research Coalition in 2022 in order to introduce more science into cannabis production methods. He also does research on cut flower production and post-harvest issues. And I would like to thank you very much for joining us today and in order to share some of these really fascinating results. Please, Jim.
Great. Thank you for the introduction, Narit, and thank you for Dr. Park for inviting me to speak here today. Today I'm going to be talking about flushing. In the academic world, we use the term nutrient restriction. This is something that the cannabis industry is quite familiar with, but we're calling this an old idea with a new twist because we're going to provide you an alternative technique for using flushing for perhaps a different purpose than what you're using it for. So we'll be talking about really two different flushing systems. So, what is flushing? Flushing is, according to Ed Rosenthal, there's a multitude of flushing methods, but they all share a common goal to remove most of the nutrients available to the roots, thereby encouraging the plant to use the non-assimilated salts and nutrients still remaining in the plant. So this is a technique that's been promoted for a number of years, pretty much for the purpose of improving smoking quality, which is a very difficult thing to assess. but we'll at least show you how we've tested this hypothesis about flushing having an impact on nutrient content in the buds and what impact it might have on your facilities. Obviously, we can't look at smoking quality very easily. So the way we're defining flushing is we would do a continuous passing of water through the growing media or substrate to reduce the EC to a near zero value. We basically get below 0.2. And as you can see here, we would put multiple drip tubes into a container and just flush that container until the leachate, the solution coming out the bottom, was less than 0.2, and then we would stop. So we really are removing all nutrients available through the container. So we look at a timeline for flowering of cannabis. So we're looking at an 8-week process. We start short days here at week 0, and then harvest week 8. And our traditional flushing approach would be sometime in that last week. Some people go even as far as 2 weeks before harvest. We will do this flushing treatment. Some growers would define that as just ceasing fertilization. We flush the substrate and cease fertilization in what we're doing. And again, the goal is to improve smoke quality. At least that's why most growers will do it. We'll also be talking then at the end of this, or the second half of the presentation today, about flushing in the first 2 weeks of production as a means of height management. And we think this technique has a lot of merit, and we'll show you our data to support that. So we're really looking at 2 different opportunities to flush plants to improve crop production and plant quality. So in our a traditional flushing approach, we did an experiment. We grew the plants under conventional greenhouse fertilization program using a standard pre-blended fertilizer 15-5-15. We're applying it at a rate of 200 parts per million nitrogen, and we recorded growth from weeks 4 through 8 of the flowering process, and we'll show you that data first. And then we flushed the plants for 0, 1, 2, or 3, or even 4 weeks prior to harvest. So way beyond what a commercial grower would do. Sometimes we do things a little more extreme and you get to see results more clearly. So we then harvested the plants, and the diagram here kind of just shows you our experimental scheme. So we had, again, 8 weeks of short days. Week 8 we harvest, and then we flushed. We have either had a control group, which was no flushing, so therefore we received fertilizer until harvest, and then we had a treatment that received fertilizer until the week before harvest, or 2 weeks before harvest, 3 weeks before harvest, 4 weeks before harvest, where we flushed and ceased fertilization. And we harvested the plants then, and we took this canopy and divided it into the vegetative mass and the inflorescence on the tip of each lateral shoot. And so I'm going to show you data that shows you total fresh mass. So that would be this whole part of the plant. Vegetative would be the measure of this part of the canopy, and then the inflorescence is the trim and the buds in that inflorescence. And so this is what the data looks like, where we have harvested the plants after 4 weeks of short days, 5, 6, 7, and 8 weeks. And what's really, and this is the total mass here, but actually it's just the mass is measured on the y-axis, and you see total is the blue, vegetative is the green, and inflorescence is the red. So basically the blue is the green plus the red, the inflorescence plus the vegetative. And what is really quite clear, it stands out here, is that really once we've hit week 4, there's not a significant increase in the vegetative growth of that plant. All the mass that accumulates from week 4 onward is in the inflorescence. And so that actually is pretty interesting. And it feeds into our flushing in the early part of the growing cycle experiments, because if we're trying to control plant height, we need to control the vegetative part of the plant, and that's occurring in those early weeks after the start of short days. And in the latter weeks we don't want to be inhibiting inflorescence development. And so we would fertilize normally during these weeks 4, 5, and 6, and 7 in order to maximize the inflorescence growth. If we look at the cannabinoids, of course, we're growing industrial hemp, so we're just measuring CBD, but you would expect the same trends for other cannabinoids. And you can see from week 4 through week 6, the cannabinoid concentration is increasing. And this is just growth without any flushing, but this is normal growth. And then from week 6 onward, we're not really increasing the concentration of the cannabinoids. But we are increasing the yield of CBD, the total yield, throughout that from week 4 through week 8, because the growth of the inflorescence is continuing to increase linearly throughout this period. So therefore, if we're looking to extract cannabinoids, then we really want to really be fertilizing until throughout the whole crop and maximizing the total biomass, and will increase the total yield of the cannabinoids. But if we're looking, if concentration and quality is more important, then really once we hit week 6, as we show in this previous figure, we're not really increasing the concentration much. And then of course, if you go further than week 8, you're going to hit a point where that cannabinoid concentration is going to start to decrease. So if we look at the nutrition in the tissue analysis of these plants, and this would be nutrition of the buds of the leaf tissue without fertilization. Excuse me, with fertilization, you see the nitrogen really doesn't change. Potassium doesn't change much. Calcium actually comes down a little bit with each of the final weeks of production, and phosphorus actually goes up some in the final weeks of production. And then we'll look at what happens to these nutrients when we actually start flushing in a moment. So again, our flushing treatments, as we showed before, we have 0 through 4 weeks of flushing, and then this is what the plants look like. Here we have on the left the plants that were not flushed, and then one's flushed 1 week, 2 week, 3 week, and 4 week. And you can see the flushing treatment is very effective at removing the nutrients, and most importantly nitrogen, out of the leaves. But interestingly enough, the buds are such strong sinks for nutrients that they continue to develop pretty well regardless of the flushing treatment. Let me show you. I'll show you a few more pictures, a side view of these plants. You can see height is not affected by the flushing duration because the height of the plant has kind of been predetermined by the weeks, the first 4 weeks of, and really the first 2 weeks primarily, of the flowering cycle. So, flushing, even though we are restricting nutrients dramatically with this 3-week flush treatment, we have not shortened the plants at all, because really the height of that plant has been predetermined by the earlier weeks. But we have, well, we haven't taken the nutrients out of the old leaves. By what we do is by no longer supplying nutrients to the substrate, then the plant has no nutrients to extract from the substrate, so it starts to take them from the older leaves and mobilize them to the new growth to support the flower development. So the plant starts to cannibalize itself essentially, and you can again see that here. The inflorescences look much the same, but the leaves that are the suppliers of nutrients to that new growth, they become the suppliers of nutrients to the buds if there are no nutrients available in the substrate. But what you do see is the buds stay pretty green. They are the sinks, and the mature leaves are the sources of nitrogen and other nutrients, mobile nutrients like phosphorus and potassium. And so those nutrients get mobilized from the leaves to those buds to really support those flowers. The plant's trying to survive and put its energy into the flowers, which are in normal situations, it would be producing seed in order to have the next generation of plants. Of course, these are just female, so we end up just tricking the plant because seed are not going to be produced here. And looking up close again, you can see the buds. The buds stay, pretty green for the most part. The sugar leaves in here are turning yellow, with a really severe flush duration. Of course, nobody is doing 3 and 4 weeks of flushing. We're doing 1 and at the max 2, and you can see those buds look, normal. So the flushing doesn't do anything physically to those, or really doesn't affect their color very much at all. Now, if you look at the nutrition content with these flushing treatments, what you do see is with nitrogen, there is not actually, and with all the nutrients, there is no statistical difference in the nutrient concentration after 1 week of flushing. After 2 weeks of flushing, you start to see some statistical differences, but these are pretty small differences when you get down to it. And again, on our really extreme flushing treatments, you're still not seeing really extreme changes in the nutrient content. If we would simply change the fertilizer program, we would alter the nitrogen content a lot more than what we're seeing here with these flushing treatments. So our conclusion, and the other thing you see is nitrogen does come down starts coming down weeks 2, 3, and 4. Again, it doesn't get real low. It's still at 3.5%. The tissue. Potassium doesn't change significantly. Calcium often mimics or has an inverse relationship to nitrogen. So as nitrogen comes down, calcium actually, the concentration goes up. And the phosphorus concentration here also went down. But again, these are not real big changes considering how severe those plants were having nutrient restriction. So our conclusion is actually then, a week of flushing or even 2 weeks of flushing has very little impact on nutrient content, if any at all, and therefore is not likely to be the reason why we would flush to improve smoke quality. We think there's, if in fact smoke quality is improved with flushing, it's not due to the nutrition, it's due to some other factor. So if we look at the effect again of flushing duration on the total mass of the plant, again, 1 week of flush, and these letters A show that there's no statistical difference in the total mass or the mass of the inflorescence. And of course, vegetative would not have impacted by even 4 weeks of flushing. You do start to see a significant decrease in inflorescence mass with a 2, 3, and 4 week flushing. And then that starts to become fairly significant increases or decreases here. But again, that's not what we're recommending. But it does show that a week of flush, which is what most commercial facilities will do, is not having much of any impact, and no impact at all probably on mass accumulation in the buds and inflorescence. We do break down the inflorescence into buds and trim. And we do see, the buds start to be significantly lower mass after 2 weeks of flushing, and then quite a significant increase or decrease in mass after 4 weeks of flushing. The trim really hasn't changed significantly over that time. So again, 1 week of flush, you're not harming yield. And so we, 1 week of flush is we think a safe thing to do. 2 weeks, you are starting to inhibit your yield. But CBD concentration, and this is true of many crops that we grow. If we decrease the yield, we actually increase sometimes the goodies in that plant. We increase the concentration of some of the desirable products that are in that plant. So yield and quality are often inversely related. If we have a lower yield, we end up with a higher quality product. And that's kind of what we see here. We end up with a higher CBD. A trend is upward in terms of the cannabinoid concentration with the flushing duration, because we are impacting the size of those buds, and therefore we're concentrating the cannabinoids more. And whether this is a tomato or a cannabis plant, if water and fertilize a tomato plant, we get really large fruit, but poorer quality. And so there's this balancing act. So the bottom line is, with flushing is, what is our goal? If we're just looking at extractable products, then we really probably don't want to flush. We probably want to just maximize biomass production, accumulation. If we're looking at a quality product, then there can potentially be some benefit with flushing and some stress on the plant in order to actually not maximize yield, but maximize the concentration of the cannabinoids in that product that we harvest. So again, you can see here, flower, the yield in terms of cannabinoids is directly and linearly related to the flower size. So it's just kind of nice data to see. So, we reduce flower size, we do reduce yield, but we do also improve cannabinoid concentration. So our conclusions with the flushing portion of this, the traditional flushing approach, where we're flushing at the end of the crop, is that again, if we're looking at yield as being the most important thing, then flower bud dry weight will be negatively impacted by flushing for more than 1 week. Again, 1 week, not a statistical difference. More than 1 week, we do get a difference. And thus, this really makes little sense if we're exclusively harvesting product for extraction. But if quality is concerning, then we do get an increase in cannabinoid concentration with increased flushing. So again, there's a bit of a balancing act there in terms of managing yield and quality. So in terms of the nutrient concentration, flushing for 1 week has relatively little to no impact on nutrient concentrations in the buds, while the foliage, you can see by those pictures, is greatly impacted. What you're seeing is a mobilization of nutrients, the mobile nutrients, which is nitrogen, phosphorus, potassium, magnesium, sulfur. Those are being relocated within the plant, translocated in the plant from the old leaves to the buds to try to keep those buds healthy and developing. So cost is an interesting thing to consider here when we talk about flushing, because when we're thinking about fertilizers with the cannabis industry, there are kind of two approaches. One is some growers take what I would consider the typical commercial floriculture ornamental greenhouse production fertilizer program, which is what we did in our study. When you're using inorganic fertilizer salts, your fertilizer costs are really low. So a typical ornamental grower looking at fertilizer being 1% of their input cost. And so restricting fertilizer flushing would have very little impact on your bottom line profitability. But if we look at cannabis growers, Cannabis Business Times survey from last year said that half of cannabis growers spend 20 to 30% of their annual cost on fertilizer. So if those numbers are accurate, and we do know cannabis-specific fertilizers are very expensive relative to your standard inorganic fertilizer salts. If you flush for 1 week out of an 8-week crop, that's a pretty substantial. It's a 12% decrease in your cost. So that's your fertilizer cost. So that's pretty substantial if your fertilizer costs are this high. So if flushing helps or doesn't hurt, then why not flush for a week just to simply save fertilizer cost? And if flushing does improve smoke quality, which a lot of people report that it does, this is, again, very hard to measure. And studies that have attempted to do this have come up with varying results. It seems clear that there's not a change in plant nutrient content in the buds for even a 2-week flush that we would think would have any impact on smoking quality. We expect there's some other effect happening. So for example, we do know a lot more about tobacco products, and the carbohydrate forms and concentrations in tobacco products do influence the perceived smoke quality. And of course, if we're severely restricting nutrients, we're going to be inhibiting photosynthesis. I think that's safe to say. And if we're inhibiting photosynthesis, we would be, reducing the amount of sugars and starches, and certainly changing the forms of the sugars that are in the plant. So, this could be the reason that you may actually see a perceived benefit. We don't have data to support this, but it, based on tobacco literature, it makes some sense and would be worth looking into with further research. So the second part of what I want to talk about today is actually then taking this flushing idea where we terminate nutrition and actually moving it to the beginning of the production cycle. So we're flushing at the start of short days. So when we transition from 18 hours to 12-hour photo period. And this has a lot of benefit. And what we're looking to achieve is smaller, more uniform plants and more uniform buds or inflorescences. And so in our experiments, and we've spent a good bit of time doing this over the last couple of years, so we're pretty confident in our results. We do see increases in bud mass and cannabinoid yield on an area basis per square meter of grow space. We do see improvements in the bud to trim ratio, and we see improvements in bud uniformity. You don't have big buds on top and small buds down in the canopy. And I think, we haven't measured this, but I'm pretty confident you would also see more uniformity of cannabinoid concentrations across all of the buds, rather than in a big, tall cannabis crop, you're going to see gradients of cannabinoids from the top of the plant to the bottom. You have shorter veg times and faster crop cycles with our concept here. And you eliminate the need for using netting or support system, which has a huge benefit. I think the netting systems are a major headache that we don't need to be dealing with. And probably the most important part of trying to control height on cannabis is reduced harvest time and labor. So right now, the growers that I visit, they seem to have a bottleneck at harvest where there's a lot of work to do in that at the time of harvest, and harvest is slow and laborious. What we have done is we are spending more effort in the early part of the production cycle. So we're shifting that labor early in the cycle so that when we get to the harvest week in that room, harvest is quite fast. I can harvest a plant in a minute, and you can see commercially, a worker harvesting 2 plants in an hour. They're doing so much trimming because the plants are so big. So I think that has a major benefit. And of course, a smaller plant is well suited for multi-tier systems. It's kind of obvious. So this is kind of what we're shooting for, and we're calling this our Cansedia approach. So it's we're taking a cannabis plant and growing it like a poinsettia, because the 2 plants are very, very similar in their production schedules, almost identical. If you can grow a poinsettia, you can grow cannabis, and vice versa. You do the exact same things at the same time, pretty much. And with a poinsettia, we're growing a plant that is, 12, 14 inches tall, 12, 14 inches wide, all the flowers in the top of the canopy. Plants are grown very high density, but very uniformly. Every plant looks the same in there. And so this is kind of what we're looking for, is a canopy where all the inflorescences are right in the top of the canopy. Very easy for me to harvest because I just go and do a snip, 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 and basically I'm done. I dry them, and I don't have to go through a canopy and treat all, you have all these different sizes of buds, and you have buds all through, a foot or 2 foot of canopy. This is so much easier to harvest. And so to do this, we need height control, and we're using flushing as one of the techniques to do this. So this is our philosophy for height management on our Cansedia approach for growing cannabis. So what we've observed, and as has been seen, I think, by growers for decades, is that when you transition from long days to short days. You go from 18 hours to 12 hours. That is when the plants stretch. The internode elongation is very rapid, and you get very large internodes, and it's because you're switching to this short day. And so, and it's the 2-week jump or leap or whatever some people call it. And so we know this is when a lot of the stretching, if not all of the stem elongation, is occurring in these 2 weeks. So what we're wanting to do is target our height control during these 2 weeks. And we don't have plant growth regulators like we have in the poinsettia world, so we have to use another technique, and we will use flushing as that technique. So what we do is after the first 2 weeks, the new growth is almost entirely within the inflorescence, the flowering portion of the plant. So therefore, those 2 weeks are the critical weeks to control total plant height. And so if we're trying to manage plant height, there's really 2 things we're looking at. We're trying to minimize the vegetative period, the time that they're in 18 hours, so that be as short as possible. And that can be as short as 3 weeks. So we can come out of propagation in 2 weeks, have a week of long days, and then go to short days. Some cases we go straight to short days after propagation, but maybe a week in long days, but we're shortening that period. That helps a lot. And then to prevent that jump that's going to occur in stem elongation in the first 2 weeks, we will focus on that time by using a flushing treatment. So we do this fertilizer restriction during 2 weeks, the first 2 weeks of flowering. And then the plants return to normal fertilization practices after 2 weeks. So then, because after those first 2 weeks, then most of the growth is going to be in the inflorescences. So we don't want to have nutrient restriction while those inflorescences, the buds, are expanding. And so we want normal, healthy fertilization from weeks 2 through 7. And then again, we can flush on the end if we want to. But we have to have good fertilization 2 through 7, or we'd have pretty lousy plants. So then our second experiment that we're talking about here is flushing and fertilizer restriction. So we'd actually flush and then do not apply any fertilizer, either 0 being, well, they get fertilizer like a normal plant, or for 1 week we do this treatment, or for 2 weeks we do the treatment at the start of short days. Again, as soon as we transition to the 12-hour room, the flowering room. And what you can see is this is an overhead shot, so we're not looking at height here. You're just seeing the width growth is also tremendously impacted. And this is an important part, because if we restrict the width of the plant, we can put more plants in a given area. And that's how we actually get higher yields per square meter. So 1 week flush, the plant still looks nice and green, but is definitely not expanding normally. And then 2 weeks flush, the plant's looking pretty rough. But cannabis is a plant that responds to fertilizer very well. And so once you start fertilizing this plant, it starts to grow quite well again, and it's green very quickly and healthy, but it is now much smaller. And the growth that you achieve after week 2 is primarily in the inflorescence, not in the stems. And so this plant may look a little rough, but it actually works pretty well. And actually what does happen that is a benefit, you can kind of see the yellow leaves in the lower part of the canopy here. It actually reduces the amount of leaf trimming you have to do, because those leaves actually fall off themselves when you do a severe fertilizer restriction for 2 weeks. So this picture was taken right at the end of that 14-day period. So these plants have gotten no fertilizer, were flushed and got no fertilizer for 14 days, and they look pretty rough. Now, you don't necessarily want to do this on all varieties. What we're going to recommend is on more compact varieties, a 1 week flush is sufficient. On more real vigorous varieties, 2 week flush has some real value. If you do 2 week flush on a compact variety, they'll be too short. So here's our plants with no fertilizer restriction after short days, 1 week and 2 week. So you can see how we really start to impact the height after 2 weeks. We impact the width quite a bit. And so when we measure the width of these plants at the end, what we've determined is we would be able to put 3 of these plants on the left in a square meter, 5 of these plants, and 10 of these plants. And that's where the value is, because you do reduce yield per plant with this technique, but you increase the plant density on the bench, so you end up with actually higher yield on an area basis. So our conclusions on the second part of this, using flushing at the start short day, is that fertilizer restriction decreases plant size and per plant measurements. However, smaller plants are more efficient on an area basis if they're grown so that they are just closing the canopy when they're at maturity. And so you end up with higher flower bud mass and higher cannabinoid yield on an area basis with these smaller plants. Again, the optimal duration of fertilizer restriction at the beginning of short days will depend on the variety's vigor and the growing conditions. Warmer temperatures, vigorous varieties, you need, I think, a full 2 weeks of this flush treatment. Again, cooler temperatures, shorter varieties, 1 week is sufficient, but you really will cut down on internode length because there's just not enough nutrition for those internodes to elongate the width. So again, late flush, potentially improve smoke quality, don't really increase or decrease nutrients, but maybe there are other things that we are impacting that have some benefit. Early flush is really a fantastic height measurement technique that you should consider experimenting with on a small scale before implementing on a big scale, but we think there has a lot of merit. Getting rid of nets and support nets, having faster harvest time, I think there's a lot of merit. And then, of course, the improved yield per square meter speaks for itself. So the graduate student that's been working with me on this project is Mike Alden, and so he is more of the expert on this than I am, and would be glad to share more details with you if you have an interest in reaching out to him via email. He'd be glad to respond to your questions. I'll be answering questions now, but if you want to discuss this in more detail in your specific situation, Mike is the real expert, and these are concepts that he has developed and understands well. So with that, we'll take questions.
Great. Jim, thank you so much for a fascinating talk, and especially looking at both sides of flushing is really fascinating, especially since there's so many questions and that have been, people are asking generally about how to agrotechnics suitable for the first couple of weeks after flipping. So this is really interesting. And there are a lot of questions. Start with one. The results you showed for increased in biomass, in fluorescence biomass, without a change in CBD concentration are very interesting. Do you think that in order to increase yield without changing the chemical quality, we should try to push agrochemical production or techniques at this last stage of development?
Yeah, again, it depends on what you're marketing. I think pushing bud growth at the end is often not a good idea if visual perception of the inflorescence is important. And in most growing situations, it seems to be very important. The consumer mostly seems to want a very dense, compact bud. And if you push growth to the day you harvest, you are not going to get a dense, compact bud. You're going to get a looser, fluffier bud. And so if your consumer doesn't care, yeah, if you're just interested in yield, push them till the day of harvest. But my conversation with growers that is not usually their market. The denseness is a really important characteristic, and actually I think flushing can help with this too. You prevent that late cell expansion in the inflorescence in the buds, and usually that's just not, you just don't want to be promoting a lot of cell expansion that last week.
I agree. And I think that the last question also deals with genetic variability in the response. Without flashing, the results showed an increase in fluorescence biomass all the way up to week 8. Do you have an indication if this is a general response of cannabis cultivar, or is there some genotypic variability in this response?
Yeah, there is certainly going to be some. I have seen some data where biomass, starts to max out or before week 8. So yeah, I think there'll be some variation for sure. Yeah, but I certainly it's expanding through week 6 and into week 7, I think, for all varieties. But that last week, and also the challenge here is defining when is harvest. That's not always a clear thing. What characteristics are you defining as a harvestable bud, and I think that will vary as to what the mature bud looks like, and so that yeah, I think different growers will use different definitions for when it is at a harvestable stage. So yeah, so you're gonna have a linear growth up until when really there's a point where it is going to plateau, and that you may harvest at the early part of that plateau, or you may want to see a more mature bud and harvest later in that plateau, but there will be a plateau eventually.
The dynamic is interesting, and the interaction between chemistry and morphology, is fascinating, and superimposed on this genetic variability is a very interesting and challenging thing.
Yeah.
The next question is the results showed that there is no changes in CBD concentration between week 6 and 8 in the control treatment. Do you have information about changes in THC? I mean, should we expect THC also not to change?
I would expect them to be. I would expect them to be, identical. I don't have any THC data. I guess we do have THC data in that we do get THC data when we do our cannabinoid analysis. So there's really low numbers, but they do follow the same trend as CBD. And I would expect the same thing would happen in high THC varieties. The CBD is going to track the THC numbers, and vice versa.
Yeah, often with nutrients, I mean, we find general trends, not for all cannabinoids, but for many of them. So that's interesting. The next question deals with the technique of flashing. I mean, in what growing media were the plants cultivated for the flashing experiments? And I wonder how much nutrient remained in the media after flashing and can become available to the plants during flashing.
Yeah, good question. We were using a standard peat-based media that would have some pine bark and some vermiculite in it. And so that soilless culture type of media is going to hold nutrients a little bit more than if you were using a rock wool product or a foam or perlite type of media. It would probably be similar to a coconut fiber situation. But what we saw in the way we were flushing, once we flushed, the salt levels did not come back up in the following days. So it wasn't like, we just got the leachate to a low number and then the next day it was a higher number. We would let the flushing would occur for 15-20 minutes if it had to, and with that sort of flush we got down near zero basically, and if you had a media like a rock wool or a foam type product, it would be even easier, I think, to get the nutrients out. And then if you don't apply any, they're going to stay low.
Exactly. Can flushing cause plants to become more susceptible to bud rot or powdery mildew, or possibly pest issues?
Yeah, nice question. I would expect the opposite. Flushing would potentially help with bud rot and powdery mildew. In general, plants that are fertilized with lush levels of nitrogen, especially, tend to be better prey for insects and diseases. And so when you flush, you're not taking the calcium concentrations are end up being higher in the tissue. And when calcium is higher in the tissue, you would expect to have less bud rot. You would expect to have less powdery mildew too. So I think we have not seen that in our experiments. We did not see. Well, we did these experiments not during the summer months. We have a lot of bud rot problems during the summer months in our greenhouses. And when we did these experiments, we were not having disease issues. So I really can't speak to it, but I would expect that flushing could potentially, if anything, help.
About the plant architecture and effect, using more compact plants that doesn't grow in wheat that much, there's a question about this. For states that restrict by plant number rather than growth area, would you do you expect to receive any benefit from the Canacetia approach? So I guess the question is, are we getting any advantage to changing the architecture, even other conditions when we are not restricted by growing area?
Yeah, you will have more uniform buds. So you don't have huge ones and we don't have tiny ones. You have a lot of medium-sized ones, which I think for most markets, would be desirable. The bud to trim ratio is improved because the fan leaves, the sugar leaves are all a bit smaller. While the buds are similar, the actual flower part is similar size, so you actually reduce the amount of trim. So that has value since trim tends to demand a lower price than bud. And then so uniformity, size, and then uniformity across, so it's uniformity, size, and bud to trim ratio are all benefited with a smaller plant, in my opinion, and our data show that. And then what's harder to prove, I suppose, is the labor. But when you have all the flowers kind of right at the top of the canopy, of course, they're going to be uniform, and they're going to be more uniform in cannabinoids too, I'm confident of. But it's just very easy to go through and harvest the inflorescences on every stem, and it can be done really extremely quickly. And there's not this laborious cleaning and trimming and popping off all the small buds. I think labor may be the biggest benefit, but the uniformity issues are also substantial improvements. Now, the downside is what would be asking growers to do is pinch the plants more aggressively. And so you do spend some more time and labor early in the crop, but I think there's some value at shifting that labor from harvest to production. So in the plants that I showed you in those pictures, the ones that were pretty neat looking, we were pinching them 4 times. So that's additional labor. But the way we're pinching them allows them you again to have tremendous uniformity. So basically we take a cutting coming out of propagation and we're propagating a small cutting. And the first pinch is to 2 leaves. Okay, so we're not growing a tall cutting and pinching it up high. We're using a small cutting, come out of propagation, pinch it to 2 leaves, 2 nodes. Those shoots develop 2 more nodes, and we pinch them again. So we go, the first group of shoots has after the first pinch, you have 2 shoots. After the second pinch, you have 4 shoots. Then you allow those shoots to develop 2 nodes. You pinch them, you have 8 shoots. You allow those 8 shoots to develop 2 nodes, and you pinch them, and you get 16 shoots. Every single plant will have 16 shoots. A very predictable yield. Every shoot will have a flower, and you'll have 16 flowers per plant every time. We do use some canopy architecture. So if after a pinch, 2 of the nodes are a little bit tight together, we will use the things that are used in tomato production to support the trusses from falling over, the little bendy pieces of plastic. We'll use them to kind of bend the two flowers apart. So and you don't have to do it on every stem, but if you have 2 that are close together, it helps to bend them, and then they get more uniform light distribution. So we think it's worth the effort. But with our system, you are guaranteed to have 16 flowers per plant, every single plant, and they're all going to be at the top of the canopy. None of them are really tucked down in the canopy, and so again, the uniformity is fantastic. Yeah, I'm sold. I'm not sure I've convinced any growers to try this on a large scale. We have a couple growers that are experimenting with it now, so we'll have better real world data in probably 3 or 4 more months. But I think it's a winner of a concept personally.
It sounds like it. It sounds like it. I mean, it still is time consuming, but it's less time consuming than normal larger plants, and there is an advantage of uniformity in bud size and chemistry probably. So it's a better. How big are the cuttings? How big are the cuttings?
Yeah, I think there's less leaf removal time. So there's some savings in labor, and there's some, and of course you have more pots, you have more potential media, and there's labor, and you have to produce more cuttings. So you have a bigger more space devoted to propagation. But we're also propagating small cuttings, so we can propagate in a 72 cell tray rather than a 35 or a 50 cell tray. And I think we have done it. If we go really small cuttings, we can go to a 105 tray, and they root fine. And so you may not have to actually increase propagation space at all. But you obviously are increasing the number of cuttings you need quite a bit.
How large or how small are the cuttings?
We do a 5 centimeter cutting. 5 centimeter from the base of the stem to the growing point, the tip. Yeah. And then we strip the lowest leaf off of that 5 centimeter stem.
Yeah. Sounds good. Another question deals with speculation at this point of time, because unfortunately mechanisms we're just getting into. And the question is, what are the possible explanations or possible mechanisms for the increase in CBD content due to flushing? Can you speculate on this, or do you have any data on this?
Of the effect of flushing on CBD content?
Yes.
Yeah, so as we showed,
we see increase with a longer flushing duration.
Yeah,
we saw that there is an increase in CBD. Possible mechanistic explanation for this?
Oh, yeah, I think in the agronomy world they call this a dilution effect. And I made the analogy of tomatoes, and the same thing is true with wine grapes and a lot of horticultural crops. As we, if we maximize growth and yield, we end up diluting some of the important substances in that tissue. So we end up actually decreasing the concentration of them and decreasing essentially the quality. If we want to grow good wine grapes, we do not supply a lot of water and fertilizer to those crops. We grow the grapes on rocky soils, and it's quite dry, and you get much smaller yields, but much more densely packed fruit. And it's just the same thing with cannabis. You just, there's less water, there's less I guess soft growth, and so what's remaining is more concentrated. I don't think we're stimulating more cannabinoid production. It becomes more concentrated because we are not stimulating growth that is kind of unproductive.
Interesting. I think the people overall audience is very exciting and interested in the effect of nutrition on plant development and plant architecture. And the next question is related to this. Did you perform flashing during the vegetative period? I suppose as regarding to potential affecting the architecture of the plant when it's just heading into flashing.
We have not, we have not done that because I guess we don't see the reason why you would, because the goal in the vegetative phase is to minimize the time you are there. So you're not producing nodes, because it takes time to produce a node, right? Every node takes a few days for the plant to develop. So we're not producing nodes that are going to be wasted and are going to contribute to internodes that are going to give us height. So we're minimizing the number of nodes and the number of internodes, which is the way we're minimizing the growth during the vegetative phase and then the potential growth in the flowering phase. So I don't see that we would flush during veg, and then when we get this leap of growth when we flip, that's what we're trying to control. And so it's right at that time you want to be at low nutrition. So I could envision you might actually do the flushing treatment, 1, 2, 3 days before you flip. That, so that might even work better. We haven't done that, but that would actually, so when you get this stimulus going to 12-hour days, the plant's already kind of at zero nutrition. And so you're really minimizing the stretch that's going to occur. I'll say the other thing that we do in our Cancetti approach that I hadn't mentioned yet is that we actually pinch after the start of short days. Because even with the flushing treatment, for 2 weeks after the start of short days, you still get elongation. And if I really want to minimize that elongation, I will actually do a pinch. The final pinch will be 1 week after the start of short days. And this does not delay flowering, surprisingly enough, but it does take out any stretch that occurred during that first week. And because you've just now pinched it out. That is also a key component to growing extremely compact plants.
When you do this last pinching, do you do it for all 16?
Yeah.
16
so when we pinch the 8 shoots, so then we're going to get 16. When we do that 8 shoot pinch, that's occurring 1 week after the start of short days.
That means that the inflorescence that you get are not from the terminal buds of those 16 plants, probably from.
Well, no, you still get you get 16 terminal buds. You get 16 terminals.
Probably one of the lower inflorescence become the dominant one. That's interesting.
Well, the plant is short enough, and then you're only pinching to 2 nodes, so there's not a difference in height of those 2 nodes, and so you don't get a dominance of the top one so much, because they're really not. It's not like they're 4 inches apart, and so the top one becomes dominant. They're really close, and so they kind of develop closely together. If anything, the one challenge we do have is if we do that last pinch a little bit too soon, then those 2 buds end up growing right like this, and then we have bud rot in between, because the two buds are, the base of them, they're kind of like Siamese twins. They're almost attached, and so we need to make sure the internodes are far enough away at that last pinch so that those final two buds actually have some separation, so we don't create a real humid environment by merging those two buds together, if that makes sense.
Yeah, then it's fascinating.
Yeah.
The art of making the plants do whatever we want them to do.
Yes, yes. This is horticulture.
At its best.
The art of manipulation.
The
Yeah.
art of manipulation, right. Next question is, what was the level of consistency in the cannabis plant height when subjected to flashing during the first 2 weeks of shore days? And I guess that the question is probably deals with, we know that many times when we stress the plants, they lose a little bit uniformity. So I guess the question is, since we stress them with nutrient stress, how does it affect morphology, or in this case, height?
Yeah, that's an interesting question. We did not see problems in this. Again, our flushing treatment's pretty severe. We run a lot of water through the pot, and so all the plants kind of get down to zero pretty uniformly. I think if you were not careful and if you were only measuring leachate of one pot and you saw this one is down to 0.2 EC, I'm stopping the leaching treatment. And there are other pots that are not getting as much water running through them, and you had some variation, you're going to create variation in height. But if you take them all down to really get them to zero, and you can't get lower than zero, so if you just let it run long enough, or plenty long, that you're getting really down to zero in all those pots, then uniformity has not been an issue. If you didn't do the flushing treatment really well, I could see you create some variation, because the EC may be 0.3, 0.4, 0.5, and then you're going to get a considerably more growth than a pot that's down to under 0.2 EC.
And probably also the population of the cutting that you start with, the fact that they're smaller, very uniform.
Yeah.
Well.
Absolutely. We have to come out of propagation. We take uniform cuttings off of the stalk. We propagate uniform. You start from day one with uniformity. And if you don't have uniformity of cuttings, then you need to at least do grading at that point. But the goal would be to get good at this so that they are really uniform. They should all be like little soldiers, everyone identical. And I think I didn't talk about stock plant management, but that's one of the themes that we've really started with when we started with Cannabis Research 3 years ago, was growing mother plants that were we called them chia pets. They are little porcupines with very uniform shoots, and not these giant mother plants. You pick a giant mother plant and take big cuttings off of them, you are going to start with poor uniformity. But we very aggressively take the cuttings off of the mother plants. And so a shoot comes out, we take the cutting, even if we don't need it, we throw it away, so that we're taking cuttings at the right stage of development, and they're very uniform. And if you let the shoots get long on a mother plant, that you create poor uniformity from day one. So it all starts with the mother plants and cutting harvest, and then doing well in propagation so that rooting is uniform. It all starts early. You can't, if you start out without good uniformity, there's no way to finish uniform.
Yeah, you're right. Another question deals with the effect on flashing on the microbial community. So do you believe that flashing treatment could potentially flash out microbial communities in addition to nutrients, which might have an impact on growth and ultimately influence cannabinoid production? So we have
that's an interesting question. I guess we don't probably have any, I'm not aware of information that suggests that the microbial community is particularly important in kind of soilless systems that we're using. So I don't know the answer to the question. I would expect flushing certainly could impact the community. It may, I guess you could make an argument that mycorrhizal fungi there may be some benefit to the plant. When the plant's under a low nutrition stress, the mycorrhizae are more valuable. If we grow plants with a lot of nutrients available, we don't see any, real impact of mycorrhizal fungi because, the plant's already got plenty of roots to extract all the nutrients it needs. But if you have a more stressful situation, the microbial community becomes more important. No data and this speculation. I don't know. It's the answer.
Yeah, I think that's another issue that also we have very little data on for cannabis is the effect of endophytes, so this will be bacteria in the inflorescence as well on chemistry and production of cannabinoid and other secondary metabolites. So again, it's another area that we have very little to none almost information on.
Yeah.
We went overboard and there's there are interesting questions. I just want maybe to answer one very briefly. There was a question about how did you apply fertilizers? The fertilizer was applied via foliar or directly to the substrate. So we know that it was applied to the substrate, but maybe a few words about potential foliage fertilization if you have any experience with it.
Yeah, we have not done foliar fertilization with cannabis. We do it on some ornamentals. We usually only do it in situations where we are not able to supply adequate nutrition through the root system. And so those examples would be in some crops, foliar applications of calcium can be very beneficial because the plants do not transport enough calcium to the developing fruits and flowers, but that would not be the case with cannabis. Cannabis gets plenty of calcium into the flower buds. So I would see, and we've tried, because we know calcium reduces botrytis, which is the botrytis infection is what causes bud rot on cannabis. And we know with other species, calcium concentrations in the tissue are very important for that tissue to resist botrytis infection, but we have not been able to show any benefit of calcium applications foliar or in the substrate on cannabis. Cannabis seems to get plenty of calcium into those buds without foliar applications. So that's the one example of foliar application. The other one would be if you have an unhealthy root system, you can see nutrient deficiencies pop up, for example, iron deficiency. And so you can do a foliar application to remedy an iron deficiency or other minor nutrients. But ideally, we grow healthy root systems. So really, foliar applications I see as more of a Band-Aid. It's not a cure. What we're wanting to do is have a good nutrition program and a healthy root system, and then we really don't need to be doing foliar applications. So I don't know of any situations where foliar applications would be a standard management procedure for cannabis.
Jim, thank you so much. This was a fascinating presentation and fascinating discussion for the questions. And thank you for the audience, for questions. And we were very happy that you came. And we invite all of you to join us, for our monthly webinar, which we have a webinar once a month. If you haven't registered yet to receive the advertisement of the webinars, you're welcome to do it on the website. And thank you very much.